Okay, we're ready to begin our tech talk today. Optimize your NX CAM with ISV simulation solutions. Questions will be answered live at the end, but go ahead and enter them in the chat as they come up. Our presenters today are Ryan Sides and Tony Lyle. Ryan Sides is a seasoned sales professional with over 17 years of experience, currently serving as a senior sales consultant with Prolim. Throughout his career, Ryan has cultivated a deep understanding of the intricacies of PLM solutions and their impact on businesses across various industries. And Tony Lyle, he's our director of engineering. Tony has over 30 years experience in manufacturing for multiple industries, including injection molding, aerospace, automotive, medical, and the steel industry. His manufacturing background includes roles as manufacturing lead and shop foreman, senior CAM programmer and CNC programmer, and a machine operator. The Tech Talk is now yours.
Well, good morning, everybody. So my name is Ryan Sides. I'm a consultant with Prolim. So my role is to really analyze customers' needs and then create a plan to solve those needs. And so today the conversation is going to be around NX machine tool simulation. So the focus really just is not just on programming, but really making sure what's simulated and programmed translates accurately to the shop floor, which is an issue in today's environment. Obviously, everybody's going after efficiencies and how we can get better. And so that really is the focus of today's conversation. So I'll cover the challenges that we're seeing out there, how Prolim helps, and then hand it off to Tony Lyle, who will kind of take a deep dive into the technical side of it. So I'm going to start the presentation off with two questions, really simple questions. Are you getting the most out of your software, and can you always trust your simulation? So, and then the goal of these questions is not really to, to get you to purchase anything else, but really just to analyze at the end of this discussion, look into what you have and are you getting the most out of it? Is there always, software is complicated. It's expensive, and so are you getting the most out of what you have, and possibly how Prolim can assist you in getting the most out of your house. So, has anyone ever had a program run fine in simulation, but then fail on the shop floor? So that's what we're trying to prevent. On screen everything may look perfect, but there might be small gaps between simulation and the real machine that can cause expensive issues down the road. So hopefully by the end of this presentation, you guys, can answer those. And if you are getting the most out of your software, and that's good. But if not, hopefully we can assist in analyzing that for you. So really, simulation is powerful. It's a fully integrated, seamless environment. But it's only good if your inputs, your models, and assumptions are accurate. So some of the things that we're seeing out there that could cause those issues are machine kinematics missing, risk of collisions, machine crashes, maybe no process simulation, errors may be discovered only during machining. Obviously disconnected data that can be in the design and the manufacturing side. So programming errors due to outdated tool data, obviously human input errors, incorrect tool definitions. I've had many conversations around that with my current customers. Fixture setups, coordinate systems can give misleading results, and then post-processor mismatches. So a lot of those will go into, obviously we want to prevent those before they go out to the shop floor. And so that's how maybe Prolim can assist in that. So how can Prolim assist? We want to really maximize your CAM investment. CAM software is expensive. So we want to help manufacturers unlock the full value of their CAM software. We want to extend beyond programming. We want to connect simulation, post, so all that ties to the shop floor. So it's just a continuous improvement that reaches all of the departments. We also want to ensure accuracy and confidence. Our services ensure programs are validated, accurate, optimized, before reaching the shop floor. And then accurate toolpaths and verified, NC code, reduce uncertainty. And then the main one would drive operational efficiencies. Like I mentioned before, everybody's looking for a more efficient shop floor. So we want to eliminate costly rework by catching errors early, minimize the unplanned machine downtime from crashes or tool issues. So currently, how we can help. We do on-site coaching and mentoring. So we'd love to go on-site with our customers and spend a day or 2 days just analyzing the process. We can take a ton of notes and just really just be that coach and mentor to you guys as far as catching stuff early, offering suggestions and how you can be more efficient. Post-processor development, 2 to 5 axis machines, machine simulation development, toolpath, everything that I mentioned before, we want to be a part of, and just analyzing your software and making it more efficient for you. And then the advantage for our customers. This is the last slide. It's the slide that, is pretty prevalent in the Prolim. So just the support that we give 24/7. We have a technical support team that reviews tickets on a weekly basis. So really just we want to be that bridge between you and your software and support you in any way that we can. I'm actually going to turn it over to Tony, who would take a deep dive more into the technical side, and then we can answer some questions at the end. Tony?
Yeah, thanks, Ryan. I'd like to just cover some of the NX CAM ISV simulation solutions that Prolim has to offer. So the NX CAM integrated simulation and verification, it's a state-of-the-art application that enables the programmer to validate toolpaths as well as machine motion through a digital simulation from within the programming session. As you can see on screen, it's running the same G&M code that the machine will use in fully integrated digital twin before it ever hits the machine. So this is going to run, you can see here, it's going to run a full 5-axis motion, and you can see all those kinematics moving around, all the axis motions on screen. So you can be prepared in the real world for the real world environment. So ISV uses CAD assemblies as seen here. This modular software also showcases material removal using full 3D in-process representations of the part, coupled with gouge and collision checking methods. I'll show a little bit more on that later. Once again, notice the actual NC code running on screen. This is what we call machine code-based simulation. But you can also bring in external code into the environment and run it in this simulation. So if you have some legacy programs and such, you can bring those in and run those. ISV eliminates the need to tie up expensive production equipment to verify manufacturability. It's fully embedded within CAM, reducing errors, since the tooling, fixtures, and part and machine geometry only needs to be created one time. This is a machine that uses multiple spindle heads. You can see them here. These heads allow different reaches and access directions and clearances using multi-axis heads or right angle heads, any sort of dynamic heads, etc. Now it's going to move over and grab one of these heads and take notice of the tool direction as it's changing based on the operation. You can see how it's in this direction while it's cutting this side of the part, but as it rotates around, you can see the axis direction changes on this head. Now the next couple of heads, there's some basic right angle heads with different configurations. Okay, and those are going to finalize those. Now, finally, another full 5-axis type of head to get into some of those really tight areas. There's some different operations for that. This is just another example of multiple heads here. Some right angle heads that we've done with different rotaries, or etc. just to be able to access different points of the part based on the setup and clearances that you have. Then here's another full 5-axis head. Notice the kinematics. Watch those kinematics working here. All right, so this simulation comes into play in these little tight areas like this. Watch how close this is going to get. However, I don't get a collision, so I know that this can be safe. There's no collision. Now we're going to move on to some mill turn machines Prolim has developed. These will use a combination of X, Y, Z, and C axes to complete the tool paths. Some operations can use either Y axis or the C axis to complete the desired milling tool path, and we can control which one you want to use on the fly, and it'll represent correctly here in the simulation. Now, I stated earlier on that you can see material removal. Here's an example of that happening. This displays the raw material as the cutting tools are removing that material. This is what we call our in-process workpiece, or our IPW. This program even has a part transfer where the subspindle comes and grabs the IPW from the main spindle and sets it up for setup 2. You see where that transferred over. Transfers over to setup 2 so it can complete the part on the opposite side of the machine. Now we can complete our part without any manual intervention or the operator having to transfer that over. But the key here is knowing that the part transfer is made safely and accurately. So we can simulate that as well. Now we will run setup 2 program here on this subspindle, and we can get a complete part. So again, just doing all of these things in a digital twin before it ever even reaches the machine, and verifying that here. This full 5-axis motion is finalizing here on this mill turn, and then we'll get our complete part represented here. Now this is a multi-channel machine, meaning it's running 2 NC programs simultaneously using sync marks or weight codes to sync up the 2 turrets in the desired sequence. You can see where the upper head is waiting for the lower turret to finish before it continues. I want to showcase collisions now. The upper head is very close there to the lower turret, but it had room. But now, as it switches tools, it does actually perform a collision, which pauses the simulation and displays an alarm and colors the colliding components. Here's another multi-channel machine. This one is going to do some pinch turning, meaning it'll use both channels to cut the OD at the same time. This uses a single operation called rough turn multi-channel. Now I have a separate YouTube video on that specifically. Check out our YouTube page for that content, along with just hours of additional CAM and simulation content. Once more, you can see the IPW here and what each tool is removing as it's processing through this tool path. All right, now it goes in for a final pass here. And now we have another multi-channel machine here. One turret cuts on the main spindle, the other turret cuts on the subspindle. We'll have a part transfer on this program too, again, to finish on the other side. Being able to simulate and verify a manufacturing process in the digital space can significantly improve the expectations that the task will be executed as planned with no errors in the real world. It's an accurate representation of the machine tool kinematics and configuration, providing users with the capability to simulate a complete machining environment. All right. Let's see, once more, we can see the assembly structure here. We can toggle on or off any components or sub-assemblies we wish for easier viewing. The simulation includes all controller-dependent motions. For example, the table rotation, cycles, macros, and specific functionality triggered by the NC program based on your G and M code, your NC program. The core benefits to simulation, though, it's reducing programming time, accelerating the machining, maximize resource utilization, achieve quality requirements safely and efficiently. The different machine types that we have produced here at Prolim, 3 to 5 axis milling, vertical machining centers or horizontal boring mills, 2-axis lathes and VTLs, mill turn machines like you see here, turn mills, whether you're using tombstones or robots, we do multiple spindles, multi-channel synchronization, all those different machine types. Some of the different features, the key points is the seamless integration of NX CAM inside NX CAM and really the whole Siemens ecosystem, such as Teamcenter. It's all machine code based simulation, so it's running your code. You can also, like I mentioned earlier, you can use external NC code and bring that in. It shows realistic material removal. It's showing gouge and collision checks between your tool, your part, your IPW, devices, tooling blocks, machine components, all these things. Displaying machine times and machine status analysis. This supports changeable devices like heads and tables, fixtures, vices, etc. Shows clamping, reposition or transferring the parts, your IPW, shows limit violations, and you can display the current locations of all axes. So I just wanted to go over a small list of some of our examples that we have developed. Feel free to come back to this list and pause it and review these, but I'm just going to scroll through some of these. But we have done quite an array of machines, machine models, control types, machine types, a lot of different capabilities that we've made throughout Prolim. So you can find a lot of our content on PostHub, which is within NX CAM. We're uploading more and more every day, so check that out. Or you can directly contact us for a quote at posts@prolim.com. Send us an email and we'll get into contact with you right away, and we can create a custom post and simulation kit environment for your organization. So I want to thank those of you who made it all the way through to the end of the video. If you have any questions, feel free to reach out to us here at Prolim. Thank you and have a great day.